shortly, please.
She got cherry lips, angel eyes. She knows exactly how to tantalize.
Hi, please, can we all, move to our seats, please? Great, thank you. Welcome to the last day of the 14th Oppenheimer Research Conference. Just a few morning house rules, a few reminders. Please, cell phone etiquette, either you turn it off or keep it on silent, please. There's Wi-Fi available, ORC 25, no password is needed. I'm assuming you all know where the bathroom is by now, so just outside to the left. What else? There are water points, so please keep hydrated, especially after last night. So use your travel mugs and keep hydrated. Recycling bins dotted about the venue, as Duncan mentioned, great effort has been made to have the bins here, so please make use of them. There are mobile phone charging points dotted around the auditorium as well. In the unlikely event of an emergency, all the emergency assembly points have been noted on the entrance to the hall. What else do I got here? So also today, as it has been in previous days, we have a full program, so we're going to ask all presenters and participants with questions. We're going to keep time quite tight. So for our plenary session today, please welcome Francois Engelbrecht, and he will be talking about the dawn of the era of 1.5 degrees Celsius of global warming. So.
Good morning, colleagues. I'm very happy to join the conference right at the end. And yes, I have some important news to share of changes in the climate system that are currently underway. The dawn of the era of 1.5 degrees Celsius of global warming. So the year 2024, as I think many people in the audience would know, was the first year during which global warming exceeded the 1.5 degrees Celsius threshold for a single calendar year. So if you look at the dark red line on that slide, you'll know that almost every single month last year had a temperature 1.5 degrees Celsius above the pre-industrial threshold. Right. This year is likely to be a little bit cooler. There's a La Niña event in the Pacific Ocean. There was one at the beginning of the year. There's another weak one that's forming at the moment. So this year may end up being the second or third warmest year on record, probably a little bit below 1.5 degrees Celsius. But the bad news is that the threshold, about the carbon budget that we have left to keep the Earth's temperature below 1.5 degrees Celsius will be burned up at the current rate of emissions in the next 3 years or so. And that means that the permanent exceedance of the 1.5 degrees Celsius level is now unavoidable. It will happen in the late 2020s, maybe early 2030s, but there's no realistic storyline that can prevent it from happening. And it's not just a statistical level. It's actually a threshold in the climate system related to certain tipping points. And that's why there's a new era of climate change that's dawning at the moment. So the first important tipping point being reached right now, as has been reported recently in the latest tipping points report, is of course the die-off of the coral reefs. So already back in 2018, the IPCC in its assessment projected a 90% loss in the coral reefs at the global warming level of 1.5 degrees Celsius. And that is something that's being witnessed across the world at the moment. But the biggest tipping point of all, of course, sits in the big ice sheets. So the threshold at which the Greenland ice sheet will melt in an irreversible way is likely somewhere between 1.5 and 2 degrees Celsius of global warming. Right, so we are on the verge of triggering that irreversible change in the system as well. That will lead to about sea level rise in the order of 1 meter this century, 6 meters in the longer term. But I would like to talk today, I would like to get to talking about the biggest impact of climate change that we can expect here in Southern Africa, in a world that has warmed by 1.5 degrees Celsius. So I'll just briefly reflect on where we are in terms of the global mitigation effort. So if you look at those slides, the light blue line, that was the carbon dioxide emission pathway into the future that could have kept us below 1.5 degrees Celsius of global warming. So that is now gone. That was probably a fairy tale all the time, but it's gone now. Right, that can no longer be achieved. We had to achieve, in that case, a 45% reduction in emissions by 2030 with respect to 2010. What we've seen since these scenarios were constructed around about 2015 were further systematic increases in emissions every year, with the biggest year-to-year increase observed from 2023 to 2024. All right, so we didn't give ourselves a chance of staying below 1.5 degrees Celsius. So the big question now is whether we can stay well below 2 degrees Celsius of global warming. So the dark blue line is a type of pathway that can still achieve that. But now we need the same scale of emission reductions in the next 10 years to stay below 2 degrees Celsius. At the current rate of warming, we will see the 2 degrees Celsius level around about mid-2040s. That's possible. So the other possibility is that fossil fuels will remain an important mix of the global energy system. And in such a case, global warming will of course reach even higher levels than 2 degrees Celsius this century. Now when those red lines were constructed around about 2015, they were being criticized as no longer realistic, that it's not realistic that fossil fuels will remain an important part of the energy mix. However, since 2015, things have changed. And now, of course, with the current administration in the US having this drill, baby, drill philosophy, that's a picture I took myself, by the way, from a television screen, when the words were said for the first time. And since we are now heading towards a world that becomes more polarized, I think, we're all aware of the current geopolitics, strong regional competition. This does not bode well for the global quest of strong climate change mitigation. So I would say it is not going to be possible to keep global warming to well below 2 degrees Celsius if the two superpowers in the world are not going to make it happen. If they're not going to use their economic power to make it happen and to give leadership in that direction, it's not going to happen. And the 2 degrees Celsius threshold will also be exceeded. And that's what we have to prepare for. The responsible thing is to prepare for that possibility, also in Southern Africa. So let us start to look at these projections of future climate change and bring the message home to our own region. So on this slide, we have temperature on the y-axis and time on the x-axis. That's just a typical point where climate change projections start with the level of global warming. So as you can see from those slides, the fossil fuel type futures take us to 3 to 5 degrees Celsius by the end of the century. 2 degrees Celsius can arrive as early as the 2040s, and a very, very, very drastic mitigation effort can still give us a good chance to stay below 2 degrees Celsius. So climate models are being used to project also the regional patterns of climate change. And these are some maps that we set up back in 2021. They were published then in the IPCC Assessment Report 6. And the top left map shows the levels of temperature increase across the world at 1.5 degrees Celsius of global warming. Back in 2021, it was still a projection. Now it is manifesting. And maybe the most important thing for us to take note of here as Southern Africans is the high rate of warming in Southern Africa with respect to the rest of the Southern Hemisphere. So if we look at the last 50 years of temperature records, there's no place that is warming faster in the Southern Hemisphere than northern Botswana and southern Zambia. So our regional climate system, with the big high-pressure systems getting stronger in a warmer world, suppresses cloud formation, more solar insulation at the surface. It's well understood why our region, because of the regional climate system, warms up faster than tropical Africa or anywhere else in the Southern Hemisphere. That's important to take note of. So a world that warms with 3 to 4 degrees Celsius in the second half of the century is a world that warms in the order of 6 degrees Celsius regionally. And I think we can just all start to imagine what the impacts of that will be. Rainfall patterns, the world's getting wetter. A warmer world is a wetter world because a warmer atmosphere can hold more moisture, and there's more moisture evaporating from the oceans. But this is not true everywhere. The brownish shades on those maps show those few parts of Earth that are projected to become drier. That's unfortunately also here exactly where we are. Right, so we are in the subtropics. So the subtropical parts of the Southern Hemisphere and a few other locations such as Mediterranean, North Africa and Mediterranean Europe, a few such locations are projected to become likely drier in a future world. And that's bad news for us. We all know we live in a highly water-stressed region. If it becomes much warmer and drier, the options for adaptation will be limited. So at our institute, Global Change Institute at WITS, we also generate these more detailed regional projections of climate change. And that's what I want to show next as I work towards the key risks that are projected for our region. We nowadays do this through a WITS NetBank chair in climate modeling. And these simulations are being undertaken on our Center for High Performance Computing in South Africa, which is a wonderful facility established by the Department of Science and Innovation. It's a high-performance computer, and that enables these more detailed downscalings of climate change over our region. So let me show you briefly just a few main messages from regional climate models in terms of projected climate change in Southern Africa. So first we will have a look at heat waves. So the present day distribution of heat waves is shown in the map at the top left, and all the other maps are projected changes across a range of different climate models. So the main message here is that there is full agreement across all climate models that heat waves will occur more frequently in Southern Africa in a warmer world. So that's not very difficult to guess. The models help us to quantify those changes. So today I can say with certainty that the heat waves of the next 10 years will be unprecedented in terms of intensity and duration. It's a very, very clear signal from all climate models, and we understand the underlying physics. And that's a number one major risk. Before we even think about impacts on crops, cattle, biodiversity, we can think about our own health when heat waves are becoming more intense and of longer duration. We still have millions of people in Southern Africa living in informal housing. If a heat wave strikes and lasts for several days, as they do, and you're an elderly person and you don't have easy access to cool water, it's life-threatening. This is a major, major, major risk for us in the next 10 years already. Now, if we look at rainfall projections, top left is climatology, the other projections are changes into the future across an ensemble of regional climate models. It gives the same message as the global map. Most regional climate models, like most global climate models, project general decreases in rainfall across Southern Africa. There's one region south of 10 degrees south where there is some uncertainty. It's only that region, and that's the Eastern Escarpment area of South Africa. So in this regional ensemble, about 1/3 of climate models project rainfall increases over the Eastern Escarpment, and the other 2/3 decreases. This is not a democracy vote, and we don't know who's right. Is it a 1/3 or a 2/3? That's not clear. So we have to prepare for both futures in Eastern South Africa. But at the same time, most climate models are projecting an increase in extreme rainfall events, the type of rainfall events that bring flooding, in Durban, for example. That type of event is projected to occur more frequently in Eastern South Africa, even though most climate models are projecting decreases in average rainfall. Most climate models at the same time are projecting increases in extreme rainfall. And that gives us an idea of the change in the nature of rainfall. What about soil moisture? All climate models agree that soil moisture will be decreasing. And that's because of the drastic increases in temperature. So the higher the surface temperature, the higher the evapotranspiration rate, and the drier the soils. And that has direct implications for the length of the growing season. It's getting shorter in Southern Africa. And the length of the burning season, that's getting longer. So to summarize the messages for Southern Africa before I talk about the major risks, in terms of the general patterns of climate change, I'll briefly summarize. It's a region with a very strong climate change signal in terms of temperature increases. The rate of temperature increase is very high compared to the rest of the southern hemisphere. It's a region that is likely to become generally drier, but there's uncertainty over the Eastern Escarpment area in terms of the average rainfall change. However, over that region, there's a very clear signal of increasing extreme rainfall events. And two other aspects I haven't mentioned and haven't discussed in detail is about the fact that we have very strong evidence of a shorter rainy season. So spring is clearly projected to become drier in these climate models. And at the same time, in terms of year-to-year variability, we don't expect major changes in terms of El Niño and La Niña. So El Niño, La Niña signal is projected by almost all climate models to persist into the future. And that's a bit of good news. It means even though the system is projected to become generally drier, there will always be good La Niña rainfall seasons. Of course, one needs to be careful, especially in the east, when a La Niña season is approaching in terms of flood risk in eastern South Africa. So now I'd just like to conclude, take maybe 5 minutes more, to talk about what we see at the Global Change Institute as our biggest climate change risks in Southern Africa from the perspective of climate hazards. Right. The first I'd like to talk about is the possibility of a category 3 to 5 tropical cyclone reaching us in South Africa. Right. So there has been one instance where a tropical cyclone moved into South African territory in the historical record. It's Tropical Cyclone de Moina, 1984, right? January 1984. When I mention this to my students, they don't have a clue what I'm talking about, but here I can see some people that will remember it. I also have a vague memory of it. Now, can we have a category 3 to 5 hurricane reaching South Africa? De Moina, strictly speaking, wasn't even a category 1 hurricane. So we did have 2 unprecedented cyclones in the last 7 years. Idai, 2019, category 4, and Tropical Cyclone Freddy, which was a category 5 cyclone east of Madagascar. Both of these cyclones eventually killed more than 1,500 people in Africa. They were the first tropical cyclones in the historical record that killed more than 1,000 people per cyclone in Africa. So we have strong evidence that tropical cyclones in the Southwest Indian Ocean, they are getting more intense and they bring more rainfall than in the past. But can they move southwards? And the answer is unfortunately yes. The Mozambique Channel is getting warmer. They can sustain themselves now further to the south than 50 years ago. And that is the insert there at the bottom right is from a weather forecast issued, I think it was in February this year. A weather forecast actually showed a tropical cyclone going to Durban earlier this past summer. Now, it didn't materialize, as we all know. The next day, the forecast showed something different, which eventually happened. The system moved out to the south of Madagascar. But the conditions are already there that's making a southward movement possible to Richards Bay or to Durban. So we are currently trying to quantify the likelihood of this happening in the next 10 years. So then I would like to talk about devastating droughts. 2023-24 had a devastating drought north of South Africa. It also impacted on us, but it was worse further to the north. Zambia and Zimbabwe lost 70% of the maize crop. Lake Kariba was at one stage at 4%, lowest level since 1959, with huge electricity impacts on Zambia via the hydropower. So the IPCC back in 2018 already projected the likely collapse of the maize crop and the cattle industry in Southern Africa under 3 degrees Celsius of global warming, purely because of heat stress combined with drought. And so that's a major tipping point. But if we take into account the socioeconomics of farming, shouldn't we expect that tipping point to be reached earlier than at 3 degrees Celsius of global warming? Right, that's an important area of work that we also need to pay more attention to. And then what about South Africa? Can we have a day 0 drought in the Gauteng province? Right. The Vaal River, the integrated Vaal River system has never let South Africa down. There has always been a supply for Johannesburg. Right. But if climate change makes the droughts longer lasting and more intense, and at the same time there's more evaporation from the dams, is it possible that the Vaal Dam cannot supply Gauteng via the integrated Vaal River system? And if we look at hydrological model projections of dam levels over time, with hydrological models being forced with these regional climate models, about 4 out of 10 start to simulate day zero droughts from the 2040s onwards. That's probably the biggest economic risk for South Africa. There is one model that says it should already have happened. That's also a bit of a concern. So let me then conclude by listing these points. And after that is just one further graphic. I think in Southern Africa, economically, we need to think about more day zero droughts in our cities, including in Johannesburg. Then I've mentioned that the tipping points biophysically in the maize crop, for the maize crop and cattle. But where's the real tipping point if we take into account the socioeconomics of farming? Heat waves of unprecedented intensity is a massive risk for our people in the informal settlements. I've mentioned the tropical cyclone risk at Richards Bay, maybe even Durban. It's already a possibility. And then finally, what about the fenced-in nature of our wildlife? I'm sure others must have reflected on this over the past 2 days. In many of the reserves, the strategy is to provide water through boreholes, of course. Many of you will know more about this than I do. Boreholes can, I guess, keep the large herds of animals alive during a big drought, but eventually after 3 or 4 years, the forage is gone, the grazing is gone. And without migration corridors, I'm just a climatologist, but it seems to me that there's a major risk in the context of fenced-in wildlife in Southern Africa, in the presence of long-lasting droughts combined with unprecedented heat waves. So why would I like to conclude on a positive note after sharing all of this? I think there are 3 things there are 3 positive points that I'd like to finish with. Number 1, we never have to exceed the 2 degrees Celsius threshold of global warming. With very strong international leadership coming from the 2 superpowers, we can still stay below 2 degrees Celsius. We can all think together how realistic that is, right now at least. Okay, but it's still possible, technically, to stay below 2 degrees Celsius. Point 2, we have science. I think we have a wonderful science community working in our agriculture, water security, our socio-ecological systems. So we can project these dangers. And that gives us a chance to adapt, at least to some extent, to some of these risks. And the third point is, I think it's really positive that in South Africa, government is respecting climate science. That's not the case in all countries anymore. Right, so we have a pathway here into decision-making, whether it is disaster management in terms of flood risk in a municipality, or in terms of the national water security strategy. There's a chance in South Africa for science, climate science, environmental science, to influence policy. And it's wonderful that the private sector is getting more involved as well. They also understand that there are risks. So in this country, there's a pathway from science to decision-making, and that's also really positive. I'll leave it there for today, everyone. Thank you.
Thank you very much, Professor. We have time for one question, if you're happy to take
thank
it.
you. Thank you.
Are there any questions? Please.
Good morning. Thanks a lot for your talk. I think we always hear about climate and the changes also on these big scales. But what I would like to know is to what extent smaller scales is taken into consideration in these models. And just one thing to highlight, we've got the rise of AI. And it was quite frightening to understand that one Google search equals 10, or one AI search equals 10 Google searches in terms of water usage and energy usage. And there's some large companies even stopping their 30-30 goals of reducing energy just to stay competitive. So to what extent will those large data warehouses and processing powers that we are using more and more, even in conservation, actually be accelerating us towards faster reaching these tipping points? Thanks a lot.
Sure, sure. Well, I don't want to encourage you to do yet another Google search, but if you would search, in terms of your first question, if you would do a search on climate change fact sheet South Africa, these have just been published as a collaboration between our institute and SANBI, the Biodiversity Institute. And we've written down the key messages of climate change at the district municipality level, making use of these regional climate change projections. So we can get the messages of climate change now down to the level of our municipalities. And I think it's important that our community works with as many municipalities as possible in terms of adaptation. So right now, our institute has a very wonderful collaboration with eThekwini in terms of flood risk and climate change and disaster management, and in the city of Johannesburg in terms of heat and health. But I think much broader and more intense work is needed across our municipalities. The science is there, but it must be contextualized in the context of each municipality, and there you need much more than the climate science itself. And then I think the big data centers are certainly going to contribute to accelerating emissions if they are powered by fossil fuels, of course. I've just read some articles saying that some of these data centers have a vision of being nuclear powered. And I know that in the European Union, a law has been passed that says all high-performance computing centers must be fueled by green energy by 2050. So in the end, it's about to what extent they can be fueled by energy resources other than the fossil fuels. But I think right now the tendency is that these will contribute to further emissions. I mean, some of these centers seem to be requiring energy supplies in the order of what a coal power plant provides in South Africa, which is a almost unimaginable amount of energy going into these larger centers. And so that's a real issue, I think, going forward.
Thank you. Thank you very much, Professor.
Thank you. My pleasure. Thank you.
I was trying to stay away from jokes this morning, but following this presentation, the next one is Stuck in a Rut with Juanita Vessels. I think it's quite an interesting title following such an inspiring and terrifying presentation.
Good morning, everyone. For Impala, being stuck in a rut is not about the Monday blues. It's about the most dramatic and noisy time of the year, the breeding season. The reproductive season of animals is often associated with various social and environmental challenges, such as intrasexual competition and limited resources. The ability of animals to successfully respond to such challenges is crucial for optimizing overall fitness and reproductive success. Seasonal reproduction is largely regulated by the endocrine system, where hormonal changes drive animal behavior, which in turn influence the hormonal responses of conspecifics. Impala can be regarded as an important keystone species, considering they play a crucial role in community composition, the functioning of ecosystems, and facilitating the persistence of other species. They are a gregarious antelope with a polygynous mating system occurring widely in eastern and southern Africa. Importantly, seasonal reproductive patterns are found only in southern populations. The breeding season, or the rut, of southern impala is characterized by elevated reproductive behavior and related endocrine activity. During this period, males engage in dominance battles to secure a high-quality territories that are preferred by females. So during this period, territorial males actively exclude non-territory holding adult and subadult males from their territories, which then form bachelor herds on the outskirts of these male territories. This allows territorial males exclusive access to the females within breeding herds that move through their territories. The peak rutting period of impala hasn't been clearly defined in previous research, but is generally thought to occur between May and mid-June, as this is when reproductive behaviors are observed to be most intense. However, the exact onset and duration of the rut may vary depending on the region. In response to cues signaling the reproductive season, a hormonal cascade is activated, triggering the production and the release of androgens, such as testosterone and progesterone, into the bloodstream. These hormones trigger physiological and behavioral changes that support reproduction. When an animal perceives a challenging or a stressful stimulus, on the other hand, a similar cascade is activated, leading to the production and the release of glucocorticoids like cortisol and corticosterone. This response enhances energy mobilization, which enables the animal to better cope with acute stressors. Once these hormones have carried out their functions, they are converted in the liver into inactive metabolites that are eventually excreted through urine and feces. This allows us to study reproductive and stress endocrinology in a non-invasive way. Despite being widespread and readily observable, impala remain poorly studied in terms of how their behavior and endocrine patterns vary across the phases of the rut. So therefore, we set out to investigate the reproductive behavior, space use, and changes in FAM and FGCM concentrations during the pre-rut, rut, and post-rut phases. More specifically, we assessed the spatial responses of breeding and bachelor herds to the phases of the rut, and we characterized and compared the FAM and FGCM concentrations of territorial males, bachelor males, and females over the rut phases. Data were collected at Salperian Nature Reserve in the South African Highveld. The Wilge River runs through the reserve, dividing the Izimvelu and Botlokwa sections in the west from the Salperian section in the east. As a prerequisite for conducting rut-related studies in impala, the onset and the end of the rut must be determined. So to do this, we recorded a range of reproductive behaviors from the 7th of March until the 1st of September. Given that all the precopulatory behaviors we recorded occurred throughout all the phases of the rut, we identified the peak rutting period as the time when mounting behavior was recorded consecutively each week. So from these results, we identified the rut phase as occurring between the 9th of May and the 15th of June. During the same period, we observed territorial males and females in breeding herds, as well as adult and subadult males in bachelor herds. During each observation, we recorded their geographic coordinates and collected fecal samples deposited during observed defecation events. The fecal deposits were subsequently analyzed to determine the FAM and FGCM concentrations within each sample. So for this presentation, I'll be focusing only on the results from the males due to time constraints, but please feel free to catch me during the next tea break if you'd like to hear more about the females. So overall, territorial males had higher FAM concentrations compared to adult and subadult bachelor males across all the phases of the rut, and they also showed higher FGCM concentrations during the pre-rut and rut phases. This is likely due to their increased aggression and more frequent involvement in energy-intensive agonistic interactions, as well as reproductive behaviors during these periods. When we looked a bit more closely, we noticed variation in resource availability across the reserve. Permanent water sources and the surrounding nutrient-rich vegetation were less abundant, more spatially isolated, and more unevenly dispersed in the eastern section compared to the western section. So consequently, we also divided the hormone dataset into eastern and western subsets and analyzed them separately. So what we found was quite interesting. So territorial males in the east showed peak FAM concentrations during the rut phase, whereas western males had peak concentrations during the pre-rut phase. In contrast, territorial males in the east had peak FGCM concentrations during the pre-rut phase, whereas those in the west peaked during the rut phase. So these differences can be explained by environmental variation between the reserve sections, which in turn shaped social dynamics. So in the east, resources were less available and accessible than in the west. As a result, eastern females likely began physiologically preparing for estrus already during the pre-rut phase, whereas western females likely only did so during the early rut phase. We see this reflected in female FAM patterns since testosterone acts as a precursor to estrogen. This suggests that eastern females may have advanced reproductive events as an adaptive strategy to ensure that mating occurs before conditions worsen further as the dry season progresses. Because the timing of estrus is also influenced by social factors, territorial males in the east likely invested more in reproductive behaviors during the pre-rut phase to advance the onset of estrus, whereas western males possibly invested more during the rut phase. However, investment in these behaviors comes at a cost, as it may reduce the time and energy available for defending territories. According to the challenge hypothesis, testosterone production increases more during male-male competition than during mating itself. So this explains why territorial males in the east had lower FAM concentrations during the pre-rut phase and western males during the rut phase. Reduced investment in territorial defense actually allowed bachelor males to encroach on territories. Although territorial males do tolerate bachelors outside of their territories, those that approach boundaries may trigger increased vigilance, dominance displays, and active expulsions. Investment in these energetically demanding interactions likely account for the higher FGCM concentrations observed in eastern territorial males during the pre-rut phase and in western males during the rut phase. So what this all shows us is that impala adjust their behavior and endocrine responses depending on what's happening in their local environmental and social setting during the rut. This flexibility helps them get the best chance at reproductive success. So rather than looking at reproduction as an isolated event, we need to see it as a process shaped by the broader ecological and social context in which it occurs. From a management perspective, our findings highlight that impala within the same population can face different challenges. So in order to effectively manage the population as a whole, distinct strategies should be applied to different subpopulations, especially when they are separated by factors such as resource availability. And then finally, our findings are valuable for reproduction and stress management within impala populations, as knowing when the rut starts and ends may allow managers to plan activities such as controlled burns and game counts so they don't disrupt critical reproductive events and ensure that human interventions occur outside of this critical window. I would like to acknowledge and thank everyone that contributed to the study, and thank you so much for your attention. I'd love to hear your questions, so please don't hesitate to ask.
Thank you very much, Renata.
Okay, it's a pleasure.
We have time for one question from the audience. Anyone? No. Thank you very much for
Okay.
presenting so clearly
Thank
your
you so
research.
much.
So next, please welcome Lee Baumgartner, and he will be talking about drugs, guns, and eels, the decline of angulid eels in East Africa and beyond. Thank you.
Okay, I'm sure most people here remember the first day of their jobs, or they might have even remembered the first day they went on their first field trip. And I'm going to share with you now the first field trip I ever went on. That was my office for the first field trip. It's the first day of my job. I finished university on the Friday. I drove to Sydney. We had a boat. We drove inland about 5 hours, and this is a place called the Bogan River. It's in the Murray-Darling Basin. And my job was I was with a small team of people, and we had to travel around the state. There's 300 sites we had to do that summer, and we had to catch as many fish as we could to establish the baseline of the rivers. This was a river health study. And I remember thinking, he said to me, what is my job? And the guy, the captain of the boat, Simon, he said, you just have to stand up the front of the boat with a net, and if you see a fish, catch it. And I said, I can't believe I'm getting paid for this. He said, we're on an electro-fishing boat, and I don't know if anyone's seen a big electro-fishing boat. It kind of looks like a Tesla Cybertruck turned upside down and floated into a river. It's a big tank of a thing. And at the front of an electro-fishing boat are these two arms, and they put electrical current into the water, and there's a generator at the back that runs the boat, and when you start the boat up, you hear this noise, beep, 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 beep. That means there's electricity in the water, and the captain goes, you've got two things to do. When that noise is on, look for fish, and don't touch the water. So I'm up the front, I've got my net, and I'm sitting there. Beep, 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 beep. Nothing. No fish. I look at him, and he goes, keep going, keep going. We go again, this time a bit longer. No fish, nothing. This goes on for about 30 minutes, and I turn around in the room, I said, Simon, is this bloody thing working? And he goes, your job's to watch the water, just shut up and watch the water, because you could talk to your employees like that in 1997. Now, I'm sitting there waiting, and we fished, and I had this net, and I sat there for 3 hours. And in 3 hours, we did not catch a single fish. Not one scale, not one fish, we didn't see anything. And it was quite late in the day. It's getting to about 3 o'clock, and 3 o'clock, the sun's starting to set behind the trees. And Simon goes, we'll call it a day. So he stopped, we pulled the boat to the bank. We're all a little bit defeated, if I'm honest. We didn't catch anything. This was my first day on the job, and I had one job. And I remember just sitting there, and he turned that generator off, and everything's silent. We could hear some birds in the trees. There was a little bit of wind. I could smell the two-stroke from the engine that was hitting me. And I said to Simon, where are all the fish? Where are the fish? And he said, this happens a lot. He goes, I've been doing this for 2 years now, and we quite often go fishing and we don't see many fish. And he started to tell me all of the stories. We've built dams and weirs. We've polluted our water. We've got environmental... We've stopped our flows going down the rivers. We've changed everything. We've changed the habitat. And I probably learnt more in that afternoon than I did in 4 years of university prior to that. I learnt a lot about rivers that day. And we packed up the boat and we finished, and I went on became a career as a scientist. And whilst that was a very hard day for me, because I learned a lot that day, it wasn't the hardest day I had of my career. That was 20 years later. And I was sitting in my office, and I had the old mobile phones. It was the first ones that could receive videos. And my phone beeped, and I looked up, and it was a landholder that I know that lives on a river a little bit west of us. And I opened up the message, and there was a video in there, and I played the video, and this is what I saw. He was riding his boat on the river that morning, and he'll slow down the video footage here. They're fish, dead fish. Overnight, the Darling River, which is one of the greatest rivers in Australia, had an experience of fish. 33 million fish died in a 3-hour period. That's more fish than there are people in Australia died in one night. It was phenomenal. And so Graham, who sent me the video, he was just distraught. I ended up, from that video, I ended up being on a panel that investigated those fish deaths. And from the first day I was on a river 20 years prior to that, I thought the baseline is there's not many fish in the river. We then moved forward 20 years, and the baseline had moved to the point where the river could no longer sustain life. This is a river of death right here. It was a horrible moment, and when you're on a panel investigating something like this, you hear the perspectives from everyone. So we hear landholders are angry, fishermen are angry, environmentalists are angry, scientists are angry. It's not a good place to be. But I started to understand that rivers aren't static, they change all the time. They've got shifting baselines. And a few months ago, a guy called Sacha Frost in the UK released this video, and I think it tells the story of rivers very well.
Parents lived by a river that was so clear and clean that they could drink from it. A wild river home to otters, salmon, and damselflies. As the years pass, pollution changes the river, but your parents' generation still happily swim in it, not remembering a time when you could put your head under. It's now you who live by the river. You like the quiet, though there's not much to see and the water will give you a rash. Shifting baseline syndrome is a generational forgetting that leaves us expecting less of the natural world. It's so dangerous because it's invisible. Each new generation doesn't know what it's lost, so accepts a diminished world.
And so from my first day on my job, I didn't know I was in a diminished world, and I didn't know 20 years' time it was going to be a further diminished world. And we would talk to landholders on the river who had lived there for generations, and they go, I can still remember when I was a kid and I can see the water was clear, and I could go fishing, and I could go out with a torch at night, and I could catch fish under the torchlight. You can't do that anymore in a lot of Australian rivers. And now, having done this work in a lot of parts of the world, this is typical of rivers around the world. Rivers are in decline, and fresh water is only 2% of the planet. And not a single person in this room could last more than 3 days without fresh water. But we don't value it as much as we do coal or fossil fuels or those sort of things. So I was very grateful. A colleague, Gordon O'Brien here, who many of you know, called up and said, would you like to join a collaboration? We want to start up a collaboration called the Sustainable African Rivers Initiative. We want to find a way to recover African rivers. A lot of our rivers are in decline. A lot of their health isn't that great. We'd like to work together, and I love a good international collaboration, so I happily answered the call. And so it's a great partnership. We're about 10 months into it. I'm going to tell some stories today about what we hope this will do and what the learnings from the initial part of my career can be transferred to this project. We're focusing on the Limpopo catchment, and the Limpopo catchment, this picture actually is, now if we're talking baselines, this is probably a generation ago. This is about 30 years. So this is my father's generation, let's go 30 years ago. And it looks pretty good. It's an old photo. If you look at that, you go, that's a pretty good looking river. It's got a nice amount of water in the banks. The wetlands are fairly well connected. The rain in the background looks awesome. There's a bit of rain in the catchment. It looks healthy, things are happening. People are living off the river. People are catching fish. Fish is still the most consumed protein worldwide any day, and it gives protein, micronutrients, calcium to people who eat the fish whole. It's really important. But it sustains livelihoods. These people sell the fish. They get income from the fish. A healthy river gives healthy communities. It's very, very important. But that's not the Limpopo today. These are just a few photos of the Limpopo. We could have filled up a lot of slides with bad news stories. There's fish kills. There are mining companies that are putting pollution into the rivers. That bottom photo is nappies, which are dumped directly into the river. And that puts a whole bunch of nutrients, which makes the river go green. It's not great. But if you want to work on something where the baseline's low, you're going to get good results. So we want to work really closely to try and turn this around. And it is completely turnaroundable because we did this to the river. We can undo this to the river. We just have to change a few things. And unfortunately, that ends up with headlines like this. And this is getting published in papers because people are angry. So where do you start? So you start, if you want to understand where the river is and what the health of the river is, you look at what data is available. And this is a map that Gordon's team pulled together of all the freshwater sites across sub-Saharan Africa where there was a data point. Someone had done something, measured water, caught a fish, done something and put it into this database. What we found was in the Limpopo, there wasn't many dots. And some of the dots in the Limpopo were from like the 50s or the 60s. And if you think about that, if it was you and a person and you went to a hospital, this is the analogy I give for this. You're in hospital, the doctor walks in to see you, the doctor takes your temperature, he writes it down on a chart, he puts it on the end of the bed and he leaves. You stay there for 5 weeks. The doctor comes back in 5 weeks' time and he picks up the chart off the end of your bed and he looks at what your temperature was 5 weeks ago. It's impossible to diagnose what's wrong with you with that sort of thing. And that's the data we saw here. There's no set data which is telling us the trajectories. So the first part of the project was to set up some standard areas in the Limpopo catchment where we can take long-term, sustainable, ongoing, standardized data so we can start to build a picture of what's happening. And so this is what the team has really built up over the last 10 months, to get things going, to get data generated. Effectively, what we'd like to do is work out the baseline, work out what the critical conservation aspects are, find out what they need, and then work with governments to implement actions to turn this around. What we found, and this is, I'm getting very close to the title of my talk now, is the long-distance migratory fish in the river are the ones that are suffering the most. And the most fascinating story that's emerged in the first 10 months is that of the African anguillid eel. And so I'd like to spend a little bit of time on that, sharing that with you now. A lot of these fish are either vulnerable or endangered. These are the ones that migrate a long way. So they need water, they need an absence of dams and weirs so they can go up and down the rivers. But these eels are absolutely amazing. Now, when I was a kid, they looked like a snake and they scared me and they were slimy and they smelled a little bit. But my dad liked to eat them and I could never understand why. And so we'd go fishing for eels all the time. And it wasn't until later in life that I realised how fascinating these fish were. And so I want to tell the story. You have to go out, you have to zoom out to understand what these fish are doing. So there's the Limpopo there. Let's imagine this is time 0 of an eel that's just been born. The first mystery, or the first twist in this, all eels are born in the ocean, northeast of Madagascar, these anguillid eels. So it's a long way offshore, probably in 2 to 3 kilometres deep water on an ocean ridge. That's where they start their life. They then drift on the ocean currents for up to a year. They wait for a new moon, and no one knows why. It has to be a new moon. It can't be any other moon phase. They then transform into these little transparent glass eels, and they move upstream, and they go to the upper part of the river, and that's where they stay for the next 60 years. Then on their 60th birthday, give or take, they go back to the ocean, they swim back northeast of Madagascar and they lay their eggs and then they die. Over their lifetime, it's a journey of about 15,000 kilometres, and a lot of the presentations we heard yesterday, this is one up there with one of the big migrations of animals that you'll see. It's not easy in the river if you're an eel. First thing you find when you're a baby eel going upstream is that you have to climb these big concrete walls and dams, and if you're lucky enough to do that, you'll get up to good habitat. Then when you have to go downstream, if someone's built a hydropower plant, you have to swim through a spinning turbine that's twisting at 120 times per second, and you're sitting there going, do I go now, don't, I don't, and then they go through and then bang, they're chopped up. That happens. That lasted 60 years to get back to Madagascar, and a hydropower dam chops them up. If you're in the ocean, it's not safe either. So if you're a baby eel going down, this is a boy here who's caught a tuna, a little tuna, and its stomach's full of those glass eels. So they're actually supporting big fish in the ocean. And if you're a big eel going back to the spawning grounds, you've got to dodge sharks and you've got to dodge whales. And we know this because some people have actually tag eels and try to track them back to the spawning grounds, and they've got temperature sensors in them, and all of a sudden you see the temperatures go 12 degrees, 24 degrees, 12, 24, 24, 37, 37, 37, because the only thing out there that's 37 is a whale's stomach. So they eat the eels. So that's an adult eel. This is a big one. This is fairly hard. So the adult eel has one job: to get fat. It has to eat as much as it can over 60 years to get as much oil in its body so that it can swim 4,500 kilometres. Because when they turn into a breeding eel, their backside closes over, their digestive system vanishes, it turns into gonads, and they've got one job, and that's to lay eggs, or to fertilise the eggs. They need enough oil in them to sustain them for a 4,500 kilometre journey when you don't eat. And so what that means is the eels are so oily, and that makes them tasty. And that's why my dad used to like eating them. And this is where the story has a weird twist. Unagi is a Japanese word for eel, and it's a delicacy in most of Asia. It's consumed in very high quantities, and I've even seen them in Australian restaurants. Unagi comes through in sushi restaurants, you see them all the time. The problem is, around about 40 years ago, most of Asia fished out their eel populations, and they don't have enough to sustain the demand for them. And so the bad thing for that is if you like to eat eels and you fish them out, you can't actually breed them in captivity. There's no way you can breed an eel in captivity. And the reason you can't do that is because they breed 3 kilometres deep in the ocean. You can't build a hatchery that's 3 kilometres deep. So if you can't breed them and you don't have enough left, what do? You catch them from elsewhere and you ship them to Asia. And that's what's been happening all over the world. And these are the headlines here. Massive, in the late 2000s in Europe, tons and tons of eels were trafficked to Asia. And so this happened in North America and Europe as well. And in 2020, there was more eels traded to Asia than there were drugs and guns in the illegal market in Europe. 3 billion euros, a lot of money, just for eels. And this is what baby eels look like. And so when they're caught on the black market, $6,000 per kilo is what they command. And that's what they look like. Tiny little slivery eels, and they catch them in the hundreds, put them in a bag, put them on a ship, send them to Asia. So those grey circles there are all the areas in the world where they get glass eels. And so what was happening in the late 2000s was that Europe, North America, and from India, Bangladesh, the cartels were catching the eels and shipping them to Asia. Then Interpol got involved, and Europol got involved, and they cracked down on it. So what did? They moved to the areas where there's not as strong compliance. And so now it's happening in East Africa. It's happening in Indonesia really badly. That's a lot of work that we're doing. And so now there's eels being trafficked from all over the world to Asia. In our area, it's mostly Mozambique, where we're seeing this in Africa. So Madagascar actually has a legal glass eel fishery where they export eels, but there'd be no doubt some illegal activity there. But we do know through the work we've done in the last 10 months, there is a lot of illegal harvest of eels in Mozambique, and they're being shipped. And there's actually people in Mozambique who have been shipped from Asia to harvest eels because they owe money to people in Asia, and they have to pay off their debt by catching eels. That's how big this is. So what about the poor eels? That's how they live the rest of their life. They get stuck in these big tanks in these huge high densities, and they're fed this. It's like a white paste. I can't even describe what it is. And they just sit there eating that. They still fulfill their role of getting as fat as they can, but they no longer get fat to produce more eels. They get fat back to feed the people who are going to eat them. And so that's the fate of most of the eels that are trafficked via this. So we go back to the Limpopo, what does that mean? We really want to see the Limpopo, because this is such an amazing species, we want to see eel populations in the Limpopo healthy. We want to see the glass eels free of harvest. We want to see the big eels up in the high ends of the system living happy, healthy, long lives. But we want to see that of all of our fish, but because the eels are so popular and they've got such a fantastic story, that's what I'm focusing on today. And that will take a little bit of work. Now, Gordon showed me a picture yesterday from 1967 of a dam that was built in the Limpopo, and the whole front of the dam is covered in glass eels trying to swim up. And that was 1967, so that's only, what would that be, 2 or 3 generations ago, and the baseline has changed. We don't see that much anymore these days. And that's because that's the Limpopo. The picture I showed you earlier of the Limpopo, that beautiful catchment, has changed. The baseline has changed in 30 years. There's not that much water there anymore. There's blue-green algae, there's nappies in the river, but we can turn it around. Now, I showed that cartoon earlier about the shifting baseline, but I chopped it in half because I wanted to end on a really positive note. So here's how Sasha Frost ended his cartoon.
Baselines can go 2 ways. Through education and community engagement, environmental protection and restoration, we can head towards a world brimming with life. By understanding what we've lost, we can make way for its return.
That's our vision for the SARI project. And if we can go some way to achieving that outcome and bringing the Limpopo back to the river it was 30 years ago, by collaborating with governments, by collaborating with researchers, by working collaboratively, by stamping out trafficking as much as we can, be a fantastic, fantastic outcome. And the fact that we've done it to the Limpopo means we can undo it. It's all completely reversible. And this is the team. I just have to acknowledge the team because it's a fantastic team. They travel to some very remote and difficult areas to work, but they're working very hard and they're collecting lots of data, which is great. You're probably wondering why an Aussie, who's probably quite inferior at rugby and cricket, is here talking about eels. And the thing I didn't show on one of the slides earlier is, the reason we responded to Gordon's collaboration is because that little spot off northeast Madagascar that we were talking about where the eggs go, 2 things happen at that point. Some years the ocean currents drag the eggs down the East Africa coast. Some years the ocean currents drag them the other way. And so we see East African anguillid eels in northwestern Australia, and we see them in Papua New Guinea, and we see them in Indonesia. And so what we're trying to do, and we've pulled together a big collaboration, is we're linking up African researchers with Indonesian researchers, with PNG researchers, with Australian researchers to try and crack this mystery at a whole of ocean scale. And so it'd be a pretty cool thing if we're able to do it. And that's me. Thank you so much.
Thank you, Lee. Thank you very much. Incredible presentation. Are there any questions from the audience?
Hello, a wonderful presentation, thank you. What I want to ask is, which bird species depend on this anguillid eel for their nutrition?
So many, worldwide. Cormorants, shags. We see the fish. What happens at the moment is when they're little eels and they're swimming up the river, they're so, what would I call them? You can pick them off fairly easy. What's happened in the past is those eels would have climbed up the river and they would have found good habitat, and that would have been good nursery habitat to sustain them. Now, they migrate up to these weirs and get stuck, and the birds just sit below the weirs and pick them off. So probably what we've done by developing the rivers is made them easier to eat, not by any specific species of bird, but any piscivorous bird that eats fish gets a free meal below a weir during the migration season. So,
are there any other questions? Thank you very much. Thank you very much. Please, next, welcome Matthew Child. He'll be talking about carbon credits, conservation, and the future of African rangelands.
Good morning, everyone. Thanks so much for giving me the opportunity to speak to you. My title, actually, as it was being read, sounded very grandiose, a lot more grandiose than I anticipated. But actually, it is really significant. And we heard this morning from the plenary that climate change is going to be wreaking havoc on our ecosystems in Africa, and none more so than the biophysical response of our rangelands to climate change, to increased warming, increased carbon dioxide levels. And what I'm talking about is woody encroachment. Woody encroachment is proceeding at a rate of knots, and it presents African decision makers with a key dilemma. Do we allow this to proceed and count this towards our carbon storage targets, and potentially undermine vast swathes of our rangelands in terms of productivity, biodiversity, socioeconomic development? Or do we do it the hard way and try and come up with a nuanced carbon policy that can actually restore our rangelands and combat climate change while also storing carbon? And so this is the model that I'm going to try and speak to you today about. So just to sort of set the scene, this is data from Zander Venter's 2018 paper. And he estimated that across sub-Saharan Africa, woody fractional cover has increased by 8% on average. That includes fieldwood harvesting, et cetera, et cetera. So this is net across the continent. And as we know, there's a multifaceted set of drivers that cause woody encroachment. For example, as you can see there, an increase in herbivore density can often lead to overgrazing. On the bottom left panel, fire suppression can also contribute to woody encroachment. But then key, linking to the climate change aspect, is that elevated carbon dioxide levels, warmer, wetter conditions in places are also contributing to this encroachment. So it's a key issue that ubiquitously affects our rangelands. And why is that important? Well, as woody cover increases, grassy cover declines. And as grass forage production is a key natural asset in these rangelands, this is a big problem. Not only that, but it also decreases the amount of water in our systems through increased evapotranspiration of the woody elements, as well as soil water retention, et cetera, et cetera. And it's causing a loss of biodiversity in terms of specialists that occupy these grasslands, as well as a loss of heterogeneity in our systems. So this is a big problem if we actually care about the resource base of these rangelands, as well as protecting biodiversity. So this is some work just to show you that this is not theoretical. This is some work we did with the CASA Secretariat to assess rangeland condition over there. And it really is quite striking. You can see that over a 10-year period, just a 10-year period, the proportion of significant grass trends is extremely low to the proportion of significant increasing woody trends. And I think what's even more striking about this is if you can see on that right graph, when the baseline, woody cover was skewed towards the left. So that means that there was a relatively large amount of the area in CASA that had lower woody cover and higher grassy cover. But over time, look at what's happened to that curve. It's completely flattened out. So not only does this mean on average you have more woody cover per pixel, but importantly, it's homogenizing the woody cover in these systems. So that not only means a loss of biodiversity, but also wherever you drop yourself in the landscape, pastoralists, grazers, wildlife ranchers, whoever relies on grassy production is going to have a harder time of it and limit their socioeconomic opportunity. If you look at data from South Africa, it's the same kind of thing. And what I want to point out here is that one of the ways to combat this is rewilding. So being able to convert cattle farms into wildlife areas. There's lots of evidence. Some of you have published on this in the room that shows that increasing browsers can help to combat woody encroachment. But what I want to point out to you is that that can only take us so far. So the bottom graph there shows a near linear increase in woody cover despite the rewilding efforts. So rewilding can help to sort of increase grassy cover a little bit, but there's a point towards that top right quadrant where that grassy productivity sort of plateaus as your woody productivity increases. So this is a big problem because it means that even in well-maintained rangelands, protected areas, etc., we're up against it. There is externalities that we cannot fully get control over. And as we all know, every land manager, pretty much across the board, every community, conservancy, you name it, is engaged in this problem. Everyone is struggling to do some bush thinning, clear their alien invasives, just get on top of this problem. But there's not enough funding, there's not enough resources, and oftentimes people just have to let it go because they just can't keep up with it. So, perhaps the carbon markets can play a role in trying to help this, right? You would think that this is a novel financial instrument. Maybe this can help to plug the state or donor funding gap to try and restore these ecosystems and get us going. However, 70% of the active carbon projects on this continent right now are focused on the above-ground carbon pool. So you can argue that this is almost taking advantage of an ambient trend. And there are many places, don't get me wrong, there are many places where agroforestry and planting trees is good. In our forest systems, parts of our thicket systems, et cetera, But as data from, shout out to Nikki Stevens, this is a paper that got her and I in quite a lot of trouble at various times. There are an incredible amount of land where tree planting is not the answer and is actually going to exacerbate the problems that we have here. So what we think is that we should come up with a nuanced perspective on this. We should really be treating the above-ground carbon pool as a flux, as we know, because fire, grazing dynamics, all that kind of thing shifts woody biomass across the landscape. And we should be focusing our attention on the below-ground soil carbon, the below-ground pool, which is the soil carbon pool, which actually stores significantly more carbon in our systems than the above-ground carbon pool. But this is much harder to do. So we have proposed a model where we can use what we think is the appropriate carbon methodologies to try and holistically solve this problem. So if you start out on the left-hand side and you have a system that is suffering from woody encroachment, from overgrazing, inappropriate fire regimes, whatever the case may be, what we propose is to start by just opening up that rangelands, okay? And we can do this through the production of biochar. So that is taking in that woody biomass that's been cleared, converting it into biochar. And biochar, if you don't know, is a thermochemical process that it's basically like a glorified version of charcoal, but it captures the carbon content of the woody biomass in a much more stable form, and then you can sequester that into agricultural fields or use it as animal feed, whatever the case may be. But then, so it becomes an asset to local agroecological value chains. And that's taking that woody biomass out of the carbon cycle for thousands of years, then allows us to divert what would have been oxidized into the atmosphere and safely store it. So that's the first part of it. What is then the innovative next step that would really work for our rangelands is to couple that with adaptive grazing and fire regimes, so restore the Pyrrhic herbivory model to allow us to sustain those grassland ecosystem services once you've used the biochar methodology to open it up. So let me just give you a few examples. I'm proud to announce that, to the best of my knowledge, we are the first company to have imported a particular piece of technology. It's a mobile pyrolysis unit that is able to be moved across the landscape to these disaggregated resources and converts alien invasives or woody biomass into biochar. How we are doing this, we've got a pilot project out in the Western Cape where we are helping landowners to clear the alien invasives off their riparian edges. And the counterfactual to this is that when they clear it, they just burn it. So we intercept it at that point, we convert it into biochar, there's negligible emissions from that unit, and then we secure off-takers that can add to the agroecological system in that area. We're then going to take this to our more open rangelands. So this is an example from a conservancy out in KwaZulu-Natal that have also been dealing with woody encroachment. And here, what we're beginning to show with some data is that when the soil carbon difference, so not only are you creating this new carbon pool called biochar, but as you clear those lands, as you clear encroachments and convert it into biochar, you're also getting a soil carbon gain. So not only does that solve the problem for land managers, it also enhances the soil carbon pool that you can then overlay with grazing and fire management. So when you add all of these credits up in the system, it really provides quite a long-term scaffold to be able to solve this problem over the long term. And then on top of that, we do the more traditional grazing management solution. So once you've opened up your rangeland and you can actually, you have this grassland that you can now protect, then we work with partners to produce grazing or fire management plans that can actually sustain that. So this is just a map of the Chobe Enclave, where we've done some work as well, showing the existing relative stocking rates. So you can see a large part of that landscape is currently overstocked. But working with key partners, we can begin to develop grazing plans that will help to sustain grassland ecosystem services and to combat woody degradation. And this really can work. If you do this properly, there's studies that have shown significant improvements in soil carbon in just 3 years. That study down there is actually from KwaZulu-Natal as well, that showed a 50% increase in soil carbon after just 3 years of implementation. So we think that this combination can really work effectively. This is just an example from Swalu, where we've got an active project running, and they're a similar thing through their climate change mitigation strategy. They were able to bring the proportion of grazers to browsers down, alleviate grazing pressure, and we've been able to model the sequestration in those soils since then, which has been significant, and that system is now eligible for credits. Thank you. So this is just an example of how this can actually work in practice. And lastly, we feel that there are many mechanisms to scale this kind of model up. We've just completed the carbon feasibility for sandparks, where they were looking to assess the viability of using carbon finance to meet their protected area expansion goals, which is really, really significant. And there we did really detailed case studies of exactly how the focal protected area could form the keystone of a sort of landscape scale approach to carbon. And we found that pretty much every cluster in their protected area footprints can be viable if you use this sort of combined model. So what I'm trying to say with that is that this is our opportunity to promote a science-informed, and Sally mentioned yesterday that we are working with the Future Ecosystems for Africa program to translate the science into decision support tools or project design that optimize biodiversity, carbon, and socioeconomic upliftment in ways that can bring a global south voice to what our grasslands and grassland savannas should look like, how we can promote all three of those factors. And through partners like Sandparks and many others, there are mainstreaming routes to being able to actually scale this up and resist the temptation to actually just go and plant trees everywhere and count that as carbon. So here I think we have a viable model that can provide policymakers, investors, landowners with an alternative that not only fights climate change, but actually enhances their enterprises, can improve their ecotourism offering, can generate regenerative agriculture enterprises, et cetera, et cetera. And if it works, I really think that this is probably the closest thing to a silver bullet that the carbon market can see, and I think we should be promoting this kind of thing. So thank you very much for listening.
Thank you very much, Doctor. Fantastic to see some solutions, isn't it? And if you heard me speak before, especially if they are agroecological, I think there's a great future. There's a question from the audience here.
Hey, Matt, thanks. Great talk. I just wondered what you're finding are the biggest barriers. It makes very logical sense to most people in this room, I imagine. So where's the resistance?
That's a very easy one to answer. It's cash. These projects, to do the right thing, especially for the soil carbon projects, take a long time to develop, and it is very difficult to get the landowners to take that financial risk. So you have to have a lot of capital to be able to develop this project over 3 to 5 years, make sure that there's risk mitigation, et cetera, et cetera. So there's that aspect, but also on the investor side, on the investor and the buyer side, there's still a predominant global north bias towards projects that are orientated around the above ground biomass pool. So we have to do some education around the fact that this kind of solution is compatible with the systems that actually make Africa what it is. So there's a sort of branding opportunity, and then hopefully that'll also solve some of the funding opportunities. But I think with this model, what we are excited about is that if you scaffold those two things, biochar to soil carbon, through the biochar product, you can get some cash flow into the system much sooner than you can with the soil carbon, and hopefully that will be enough to make these projects viable.
We have a couple more questions from the audience.
Thank you for a great presentation. I'm excited and curious about the biochar initiative. I don't know how expensive or hard to obtain that machine is that you had on the landscape. Is there opportunities for like livelihood creation with maybe even charcoal production for these communities for fuel? I'm thinking of programs like working for the environment, you know, the clearing of alien invasives. If we're also encouraging communities to reduce stock densities, looking also into like agriculture with the biochar, how's that model scalable to changing livelihoods and creating more jobs like that?
Absolutely. I'll give you an example. For me, I am personally so excited about the potential for that, because I really think it can be a game changer in rural areas. So the idea that we have with the particular conservancy that we're talking about is to make use of the sort of Yes for Youth program or programs like that to upskill people to be able to harvest these plants, produce the char, and ultimately create enterprises that can then sell that on, either through value-added products, either through biofertilizers or animal feed, or, you know, the sky's the limit for the application of biochar. You can use it in water filtration systems. And once that's up and running, then you have enterprises that are fully self-contained, viable, and scalable through these technology. And what we like about the mobile technology, because most biochar is actually being produced through fixed plants, but that's extremely risky. It's extremely capital intensive. It's like 30 million rand to be able to build a small plant like that. So this sort of reduces the capital risk, and you can work it out that you eventually devolve the assets to these enterprises. So that's the model that we really like. And that's not just theoretical. There are examples in Kenya where this has been done through companies that have been producing biofertilizer from rice husks, but then through different kinds of investment, they've been able to upscale that to different pyrolysis technology, and therefore earn the carbon credits that allowed them to expand their operation. So I really, really think that the difficult part is getting the unit economics to work. So again, up front, you have to find a way for some sort of blended finance mechanism to be able to cover the labor costs, the input costs, the running costs, until you become viable, and that's the trick. But we think we've got, I'll let you know this time next year if our pilot works and our unit economics are verified.
So thank you, Matthew. It's Mary Scholes from Wits University. So there have been a number of studies worldwide on the inclusion of biochar into soil. So I would just like to know, in your model, how do you take into account the fact that that biochar is going to become recalcitrant carbon when our clay content in the soils are so low, so therefore the biochar turns over really quickly. So in the short term, you get a carbon benefit, but that doesn't make it eligible for carbon credits. So how are you dealing with that in your modeling?
So are you saying once you put it in the soil, the actual soil carbon pool, or are you talking about the physical biochar itself?
No, you put the physical biochar into the soil, and some of it will be soluble, and it will immediately be released as CO2. Some of it becomes more recalcitrant, but you actually want it to go into the carbon pool that has a 2,000 to 5,000 year turnover. So how are you accounting for that in your model? Because otherwise the carbon credit stuff goes out the window.
So obviously the type of technology that you use produces varying degrees of quality of biochar in terms of the permanence of the carbon content there. On the sequestration route, we have to work with the sort of end users to monitor the application that they're doing, right? And then obviously to earn credits over the lifetime, you have to be able to prove that that carbon fraction is still intact. So we will have to do repeat monitoring to be able to just prove that that carbon is still sitting there, and if it's not, if it's being degraded somehow, that obviously just comes netted off from your total credits that you get issued. So it can be a sort of tight system if you monitor it properly. But yeah, I mean, we still also got a lot to learn about what the sequestration, the best sequestration options are to be able to preserve that carbon content. So yeah, very happy to work with you if you've got ideas on that.
Thank you very much.
Thanks.
Matthew, there were a couple more questions, but unfortunately we don't have time for. But please make sure to catch up with Matthew. I have a couple of questions as well. But so next, please, welcome Zwanda Netabeni. She will be talking about smuggling hitchhikers, ticks on trafficked pangolins, and scale poses a hidden pathogen threat.
Hello. Okay, thank you. Good morning. I just brought this guy for moral support. And it's good to see everybody back in the room after the wonderful night that we had. My name is Zwanda Netabeni, and I'm going to give you a talk on pangolins and their ectoparasites. This is actually part of my postdoc that I did with the TUT. So initially, I was going to join TUT to deal with the conservation of stone plants. But then I don't know if I should say unfortunately or fortunately, there were two other institutions that were already 6 steps ahead of us. So we aborted the mission because they have covered almost all the aims that we wanted to cover. So one of my mentors, who is the founder of African Pangolin Working Group, who is Professor Ray Jensen, he called me to his office. He was like, maybe I might have a project for you, which you may be very interested in. It's on the most harvested, or let me say smuggled mammal globally. So while we were walking to his office, I was thinking, could this be rhino? Could this be, I don't know. And then when we got there, on his table, I saw a little guy like this. And then I was like, okay, he's fond of pangolins, it's fine. And I was so embarrassed to know that these guys are mammals. I was last year's age when I know that they are mammals. But it's okay because I know some of you didn't know that, right? Right? Okay. All right, it's okay. So, all right, as I've already said, they are small mammals, and according to me, those scales were soft. But I've just learned that they are keratin scales that are very hard, and they protect them from other predators. Their whole body is used for something, like medication. Their meat is eaten, is edible, and their nails are used for some kind of, let me say, witchcraft. Or something like that. So they have very long tongues, which comes in handy in foraging as they feed on ants and termites. So globally, there are 8 species of pangolins, 4 which are endemic to South Africa, and the other 4 are only found in Asia. But just recently, there's been a mysterious pangolin species that was found in confiscated scales in Hong Kong between 2012 and 2019. So the most challenging thing that pangolins are facing is being most trafficked. And due to that, 50% of African species are now listed as endangered, and the other 50 are listed as vulnerable, while 75% of Asian pangolin species are listed as critically endangered, and they may be facing a brink of extinction in the next, I don't know, 5 or 10 years. And the remaining part is endangered. So all this is because, obviously I've mentioned, it's because they are being harvested, they're being smuggled, and this is mostly happening in Asia because they are producing all sorts of traditional medicines, and now it has shifted to African part. Now African pangolins are needed to meet the demand market in Asia. So all these pangolins are now listed in the Appendix 1, which prohibits their trade. But even though it is like that, we still see cases of pangolins being smuggled from Africa, within Africa and outside of Africa, particularly to Asia. Okay, this is not the updated, but I'll go on anyways. So, as I've already said, they are things like habitat loss, but the it's illegal poaching that we see. So, and I've already mentioned that it's because they are used for something, traditional medicine, cultural beliefs, both in Asia and Africa. So before the listing on the IUCN Red List, that is what we used to see Asia as being the region which was the destination of many smuggled pangolins and scales, as well as Europe, while Africa was the region of pangolins which were being smuggled. And then moving right ahead, I asked myself, do the community members know? Because this whole thing, this whole trafficking thing is kind of a network channel, which starts with community members that are being recruited to go harvest pangolins from the wild. Do they know that we may face extinction do they know that harvesting pangolin is not really a good thing? I mean, scientifically we know, and we also know because we read manuscripts, but then what I found out is that community members are all on social medias, they're on Facebook, they are everywhere. So my work was to go and check if the perception in social media matches the one that we have scientifically. And yes, it does. So if you find somebody in position of pangolins, just know that it's not because of lack of awareness. They're doing it for any other reasons. So moving along, what do they carry under their scales? What are they carrying from Africa to other countries? And this was motivated by that study in 2015, where they found bacteria, they found ticks, and they found mites under that. So we went on and we were working with rehabilitation centers as well as Chinese ports in our work. So any confiscated live pangolins were sent to rehabilitation before release. Then we asked staff, can you maybe collect anything that you find under their scales for us, please? And then we also received 9 bags full of scales that we did work for ourselves. We went in, scratched under the scales and all that. So from the live pangolins, we had 17 specimens that were representing 3 African species. And then we found a lot of mites and ticks. We sent mite for identification elsewhere, and then we proceeded with ticks, since we had somebody who can identify that for us. We used both morphological and molecular taxonomy. For molecular, we used the 16S RNA fragment. So that is our results. We found 5 tick species across 3 pangolin species. And then most of our morphological work was actually backed up with the molecular work. And then prior to our study, there were no sequences for that particular species, Tereli. And then we found out that all our O compactors, Ornithoderus compactus, had 98% match with Ornithodera mobata. And this just brought a contradiction, not a match between the morphological and molecular work. And we really understood that because our taxonomy was done on nymphal stage, wherein the ticks on the nymphal stage lacks distinctive characters, so they look the same. Hence, you can misidentify one for the other. So the other thing that I asked myself is, are these tick species that we found on pangolins really a threat? What do they bring? And the answer was yes, because they are vectors of various diseases, such as those that are listed there. They actually affect our red blood and the white blood cells. And then those pictures are just some of what happens when you have heavy infestation of these ticks. So they affect both human and animals. So our study just supports what was done in 2015 with one addition of, with additional first report of A. hebraeum in pangolins. And also we had 5 species that were vectors of different diseases. And now we know that the transcontinental movement of pangolins may facilitate the spread of diseases. Oh, sorry. So future direction, we're gonna continue telling people, please stop. Stop harvesting, stop smuggling pangolins. But then I think this time around we need to add in the fact that if you cannot do this for money, because most people are doing this because they are unemployed. If you cannot do this for money, at least do this for health. So future direction will be looking into actually strengthening the screening of pangolins when we receive them in, for rehabilitation and before the release back to the wild. We might also have to look at integrating ectoparasites monitoring into wildlife trade surveillance program, and also enhance awareness among wildlife officers and our vets about the zoonotic risk. Also conduct further researches, look into other ports, look into other rehabilitation center, because we might have more than we think. So for more information, you can go there and also go on Netflix, watch that movie called Kulu. I don't know if you know it. Kulu, K-U-L-U. So thank you.
Thank you very much, Wanda. We have time for one quick question from the audience. Thank you. Well, please do catch up with Wanda if you would like to ask her questions afterward. Thank you very much. So next, please welcome Tim Forsman, and he will be talking about Tulamela, gold, human burials, and a forgotten African kingdom.
Good morning, everyone. I think Monty Python said it, and now for something completely different. The shift here is obviously going into a deeper history of the human past, into quite an interesting and fantastic story about an incredible archaeological site called Tulamela, but also one that's unfortunately filled with tragedy. In today's talk, I'm going to talk a bit about that and then touch on some of the things we're trying to do to shift that narrative somewhat into a more positive history. Tulamela is located in northern Kruger National Park, just south of the Luvuvu River. As you can see on the map here, there's a couple of other sites, or 3 other sites that are indicated. Makahane to the west, Gualala Hill to the east, which I'll talk about at the end of my presentation, and then Deku. Deku is the village that the Makuleki people lived in and were removed in 1969 by the apartheid government. That area north of the Luvuvu River, up towards the Limpopo River, is now part of the Makuleki Contractual Park, leased to sand parks. These are not the only archaeological sites in the area. We've been surveying this landscape for 2 years nearly, and we've got about 100 archaeological sites dotted around this region in various different locations, and that spans from the earlier Stone Age, so from more than 250,000 years ago, all the way through to the early 1900s. Finding sites is a challenge. This is the Luvuvu River. It's an incredibly beautiful gorge along the Luvuvu River called Lana Gorge. Some of you may have visited it. From where the photographer's standing, it's an 80-meter drop down onto the river, so it's quite a tumble if you misstep. That sandstone exposure is a pretty substantial block of the landscape, and moving through it is incredibly difficult. As you can see, steep rises. There's lots of ridges and koppies behind this river region, and the vegetation is fairly dense. Tulamela is located on the top left of this image from your perspective, where you can see the river in the distance. Tulamela is down there and on the right-hand side. In fact, it's on the very edge of this sandstone exposure on the eastern side. On the western side, also on the edge, is Makahane, one of the other sites that was shown in the map. For a long time, Tulamela wasn't known. It was whispered, it was stories. There were rumors that it existed. In the 1960s, work was carried out in northern Kruger National Park at Makahane, and no one knew of Tulamela at that stage. In the 1970s, the Mazarini ruins near Palabora was excavated, and interest in the history of the park increased. And the stories fell on Tall Pienaar's ears, who asked his rangers to keep an eye out for something fantastic in the northern part of the park. On a routine inspection, climbing this hill, which interestingly has a name, and the name is Thulamela, which is where the name of the site comes from, he found this series of stone walls. He alerted Tall Pienaar at the warden, and a team was fairly rapidly assembled. They went up north, and after about a week, they were able to confirm that this site over here was something quite spectacular. And so they decided to investigate it further. In 1990, some work began, some limited excavations. This is the Luvuva River. That's Crook's Corner over there, another angle of Crook's Corner, and then just some buffalo, just because it's a conservation conference. So work began in the 1990s. 1990, 1991, excavations proceeded, limited excavations. The excavations you can see in the image over here, Thulamela is at the bottom, the Luvuva River is in the distance. The excavations were sort of at the bottom of that image. A 1 by 1.5 meter square was excavated, and inside that square, very common kind of artifacts came out. Ceramics, metal, charcoal, things we love, but also gold beads, gold nodules, and a ceramic piece with gold slag adhering to it, suggesting that there was some kind of gold production taking place. And this obviously piqued a lot of people's interest. After a few years of raising funds, getting permission, setting up a Thulamela project committee, work began in 1993. And those excavations focused mostly in what I've labeled here as the primary walled enclosure. So this is just a map of Thulamela. If you look beyond that dashed line, there's not much there in terms of walling. All the black, darker lines are stone walls, so you can see where it's concentrated. But this entire hilltop area spans about 9 hectares, and the excavations only focused on that primary stone-walled area. So this is the citadel, to use sort of a Eurocentric term, the citadel of Thulamela, where royalty, elites, wives, and so on would live. The excavations were mostly conducted in this grey blob, which is a midden. A midden is essentially just a refuse pit. And we love them because that's where all of your cultural waste, broken pots, food gets dumped. So for us, that's fantastic stuff. And that's where most of the work was carried out. They found, they had a whole series of different changes in the archaeology. So on the right-hand side, these are just soil horizons, just different stratigraphic horizons. Don't worry too much about that. But on the left-hand side is a series of radiocarbon dates. And these are quite interesting. The top date shows us that there was a presence on the site, a human presence on the site, from just before 1200. And that extended, it picked up around 1350 perhaps, and extended all the way until just after 1600. So what we're looking at is potentially an occupation on Thulamela Hill that starts before the appearance of Mapungubwe. Mapungubwe is the first urban center, the first state-level society in Southern Africa. Elites living up there, huge amounts of wealth, a massively transformational period. This site was occupied during that period, and that continued until the mid-1600s. Some of the fascinating finds that came from the work were 2 human burials. On the left-hand side, the green line going up to that enclosure, that's just a drawing of that enclosure. There was a female found. She died between the age of 45 and 60. She was in very good condition. She exhibited some malnutrition at a very young age, but other than that, she was particularly large, 1.86 meters high. And on her right wrist were golden bangles. So when they decided to excavate this in collaboration with the communities, they chose to look for additional potential burials, and they found another one in the enclosure on the far right. This was a male, also between the ages of 45 and 60 years old, but his bones, unlike the females which were lying on her side with her hands tucked in, a very common position for burials, his bones were bundled together, tied together, and placed on top of them was a trove of golden finds. An incredible variety of gold, in fact. They dated both of the skeletal remains. Oh, and by the way, he did have injuries that possibly led to his death. He may have been stabbed as well. Interestingly, when they dated the finds, initially, the chronology of these individuals placed them at death at least 50 years apart, possibly as much as 250 years apart. So it's quite possible that these individuals never knew one another at all. The fact that the male's bones are bundled together indicated that potentially this is someone who was brought to Tulumela, reinterred at the site in potentially a ritual process, a cleansing ritual, or bringing ancestors into the new settlement. And that led to some really fascinating research. Also found, some of the images are a bit blurry, but also found there's a whole range of artifacts, really phenomenal stuff. There's a few examples of the gold at the bottom there. The small little bone, it's actually ivory amulet, is a really tiny little piece, one of a kind, with very fine engravings going around it. The A at the top there is a metal gong, also very, very few found in southern Africa. There's some broken ones from Great Zimbabwe. This was found in the residential area of the chief, or the male burial, possibly associated with him. And then another important item, C over there, those are two spindle whorls, clay discs, used for fiber spinning. We don't, a lot of things in archaeology doesn't preserve, such as materials and fibers, but the tools used to produce that do, and so those are indicators for activities. Here's just a little graphic or a little show on the nice ceramics that have been found. The bottom two were found in the residential enclosures of the male and the female, respectively. And here's another range of some artifacts, including copper bangles, metal tools, and the bottom left, really importantly, glass beads. I'll talk about glass beads in a little while. So a really amazing discovery at this site. Wonderful archaeology in incredibly brilliant states of preservation. Gold, not common to find gold in archaeology, but they found a lot of it here at Tulumela. It was described by Pallo Jordan at the time as the most magical archaeological site in southern Africa. It was harnessed in the early post-apartheid years as an example of pre-colonial, pre-colonization, pre-apartheid reverence, ingenuity, innovations. And so this interest that sparked from 1993 to 97 rose quite rapidly, but soon fell. And that momentum, research, interest, focus, tourism, all subsided. And to top it off, and most tragic of all, in 2016, a large collection of the gold found in these royal burials was stolen from the museum in Skukuza. And unfortunately, when it was reported to the police 7 months later, there were no traces of where this gold could have been and no suspect. So that has gone, as far as we can tell, forever. So what are we doing to shift this story? What are we doing to change the narrative, to try and revisit and re-engage Tulumela and think about it more critically, more inclusively, more openly? Well, one of our large aims is to revisit the site, to go back to Tulumela, to open up excavations, to confirm some of the radiocarbon dates, to look for some more cultural material remains and excavate it in a slightly different way to the previous excavators. But what we're also doing is focusing on a site that predates Tulumela. In Crook's Corner, so in that red square, is our site called Gwalala Hill. If you look on this close-up, Gwalala Hill is to the top of this image. Just above the road, you can see an open patch of earth. That's the site. You don't really get a very good perspective here. It's the very last hill before Crook's Corner. So if you want to live slightly elevated off the floodplain, this is your last opportunity to do so. But this is what it looks like. Not much. It looks just like an open piece of earth. Many tourists and guides have walked through this place, not really seeing a lot. But once we get stuck into it and once we start to investigate, we found quite a lot of really lovely features. Several hut zones. There's about 6 areas of residential focus activities. There's several middens, very large middens, cattle kraals in the middle there. I'm just zooming into this section of the map just to give you a sense of it. And at this stage, we've excavated for about 3 weeks at the site, just over 3 weeks. Very small percentage of the overall space that we focused on. But we've made a number of really interesting finds. These spindle whorls, there's a large number of them at Gwalala Hill, and that's brilliant for us, because one of our key interests for this hill is how early trade networks were moving through this landscape. And fiber spinning is associated and linked to these trade systems. We've also found thousands of glass beads, a huge amount of glass beads, more than we expected. And all of this is coming from Africa's east coast. There are hut remains, that's in the center there. That's a picture of a hut floor that's preserved. On the top right are two beautifully decorated ceramics sitting in front of a stack of rocks that are upright. So the pots would have sat on top of the rocks and coal would have been put under it. And they've been broken in place. And then a lot of faunal remains, some fish remains, freshwater mussel, snail shell as well. So our interest is trade. How did these trading networks filter through this landscape and ultimately contribute to the rise of settlements such as Tulamela and before it, Great Zimbabwe and Mapungubwe? So if you have a look at this map, it's of the east coast of Africa. It's about a 3,000-kilometer stretch of coastline that the Swahili world dominated. It began around 700 AD, and trade was moving south down the coastline following the trade winds, the monsoon winds. There was a short changeover period between around about August, where the winds were a bit gusty, and then it would shift and people could sail back north. And that movement brought in the glass beads that I've mentioned. We've chemically analyzed glass beads. They're all coming from India, Indonesia, the Iran, Iraq region, Southeast Asia, and that's being traded into the interior, Great Zimbabwe, with relative ease. It's not a terrible landscape to move through, and to sites like Tulamela as well. So these sites that we're looking at, Tulamela, Gwalala, are connected to this massive global exchange network where wealth from the interior, ivory, favored ivory. Early Muslim records say that the ivory coming from the Sofala region, the inland region from Sofala, in other words, Zimbabwe and so on, was some of the most prized ivory in the world because of its malleability. Ivory, rhino horn, feathers, ostrich feathers, eggs, leopard skins, and at some stage also human cargo, was all brought into the coastline and traded up to places like Kilwa, which is drawn on the top right there, and Mozambique Island, which was eventually controlled by the Portuguese. So this work that we're looking at Tulamela, the idea behind our work is locally rooted in the sense that we're based here in South Africa like Tulamela, but globally connected through these much bigger sequences that we're hoping to tease out as we unpack our research. Thank you very much.
Thank you very much, Tim. Fascinating. We have time for one quick question from the audience. Oh, thank you. I'm sure we can catch up over coffee. Thank you very much. And now for our last presentation for the session. What an amazing award ceremony it was last night, isn't it? It was so heartwarming to see. And this. Now we're welcoming Shannon Conrady, who was awarded last year the Jennifer Award Oppenheimer, and she will share the journey of the last 12 months with you.
All right, so walking up to stage, I realized I took my fashion inspiration from the curtain behind the screen, so hopefully you enjoy my matching. But first off, just want to thank the Oppenheimer family and the selection committee behind the Jennifer Ward Oppenheimer grant for the belief in this work, which I'm really excited to share with you today, and hopefully you enjoy the little spin of a journey through the last year with me. So predicting how animals respond to climate change is pretty complicated, and I don't need to talk to any of you about the threats of global change, but one of the ways that we can look at how animals respond to global change is through predictive modeling. But predictive modeling often runs the risk of oversimplifying animal behavior, physiology, and the physical environment. And this oversimplification can lead to a weakening between model predictions and reality. So what my aim really is to strengthen that connection between model predictions and reality to actually inform conservation management strategies and action effectively. So the types of models or predictive models that you can get could look something like this. So this is work that I did before the grant that basically just shows the average summer maximum temperatures. And what we know for southern yellow-billed hornbills is that if the average summer maximum temperature is greater than 35 degrees, they have less than 50% success at breeding. And under current conditions, they're not really experiencing that. But under future climate change conditions, you see that gray area there, that is where average summer maximum exceeds 35, and they're at risk of breeding failures, or less than 50% success at breeding in large parts of their range. We can also use predictive models to understand physiology. So some of the models might look like this. pretty similar, again, looking at climate, but this time looking at physiology. And this work looked at the risk of lethal hypothermia risk for trumpeter hornbills. And under current conditions, the risk is pretty low, less than 10 days per year. But under future climate change scenarios, so in RCP 4.5 or RCP 8.5, that risk increases quite dramatically. But what this set of figures and the previous set of figures have in common is that these risk assessments were done using satellite imagery or climate-derived images or data from satellites. And that's often very coarse. Animals don't necessarily operate in the same resolution that these climate models are derived from. They operate within microclimates. So if we actually start looking at microclimates, we can start strengthening that link between model predictions and reality. And if you look over here, the blue bars are microclimate conditions, the orange bars are macroclimate conditions, and when we look at the risk of lethal hypothermia for these forest birds, there's actually a buffering when we take into account the actual conditions that trumpeter hornbills experience. So this previous work is what really drove me to ask these questions, but how can we understand the complex relationship between animals and their environments at a microclimate level, and then integrate this into evidence-based predictive models? And when I talk about animal behavior, I talk really about behavior, when I talk about the animal responses, I talk about behaviors, physiology, and the physical landscape. But for the purpose of this talk, I'm going to hone into the physiology models that I've been working on and where we are at the moment with that. And I'm going to do that for 3 different systems: Fynbos birds, Drakensberg bats, and of course the little crocodile that we heard of yesterday. So let's jump into the Fynbos birds. What are we doing over here is we're taking existing data on the physiology of birds and seeing whether or not we can actually predict the same responses that were previously collected using non-invasive biophysical techniques. So these are models based on the principles of heat flux and heat gain. And this over here, together with my master student Martinet, black dots over here represent the measured body temperature and evaporative water loss of these birds. And then in red, we have model predictions. So we see we can actually use these non-invasive techniques to really tightly predict body temperature and evaporative water loss, at least for this bird. And then we've also done it for a range of other birds. So you have this close agreement between model predictions and reality, strengthening that link that can then inform conservation management and action. So this is body temperature for a range of these Fynbos birds, as well as evaporative water loss. So we're starting to understand that these models can predict physiology, at least in the Fynbos bird systems, across a range of air temperatures. So now that we know that, or we can go into the landscape and look at, well, what are the range of air temperatures that these birds are actually experiencing, because then we can start predicting what their physiology is in that landscape. So that is the next bit of work, fire and thermal risks. So if any of you were around last year, you might remember I asked you to imagine that you're a bird sitting on a rock in the Kalahari Desert. I'm now going to ask that you still imagine you're a bird, but this time sitting in a Fynbos system like the one on your right that hasn't burned for the last 14 years. If you're in this system and it's really hot, you have a lot of options, if you're a small bird, to try and reduce the direct solar radiation that you have on you and potentially buffer you from the extremes of that hot day. But if you're in the system on the left that has burnt more recently, your options decrease quite a lot. So what we're busy doing is quantifying what the actual thermal landscapes are in environments of different fire regimes. And what we know from the talk this morning is that fire is also likely to become more prominent in the future. So not just a hotter environment, but also an environment that burns more frequently. So we're looking at, can we quantify that and then add our physiology models into that to develop predictive models. And what we're seeing is that this landscape that's burned quite recently is about 1 degree warmer on average across the landscape than the one that hasn't burnt more recently. And if you're a small bird, that 1 degree could be the difference between life or death. So we're looking at that. And then to integrate that into models like you saw Andrew speak about previously, where we're taking remote sensing data to characterize the landscape, add these thermal predictive models, add the physiology, and really understand what's happening in these systems. So now let's go into the next example, bats. So with bats, one thing that we do know is that based on their life history, they might actually show different patterns of thermoregulation. So bats that typically roost in cool sites, so those would be bats roosting in caves, are able to withstand lower maximum air temperature than bats that roost in hotter sites, like foliage, which would make sense because you're getting more direct solar radiation or sunlight from roosting in foliage. So what I wanted to look at next was, can these models actually capture these life history traits in terms of physiology in bats as well as birds? So we're just going to look at two examples over here, one from a hot, one from a cool roost site. And again, we see previously collected measured data in black and our model predictions in red, and you get this tight coupling. So again, increasing that thread between model predictions and reality. And the next step, again, is to quantify what the thermal landscape is for these bats. So we're going to be doing work in the Drakensberg, so this also just shows evaporative water loss. In the Drakensberg, and over here, again, we're going to measure the microclimates across an elevational as well as a temperature gradient, and then take this information together with satellite imagery, remote sensing products, to characterize the landscape, to validate that in terms of the thermal environment, and then to predict the physiology of the bats based on these models, which we know work really, really well. The last example is the little crocodile. So in Stefan's talk yesterday, he mentioned that they had these external temperature loggers on top of the crocodile's head. So the first step to see, can we predict crocodile thermoregulation, is to see if can we actually predict the environmental conditions that the crocodiles are experiencing. So this is the measured temperature on the head, and this is my model prediction. It's okay, it's really good at the upper end, but at the lower end, it's not quite getting that right yet. And the reason for that is because at this point, I've quantified this as a crocodile in the terrestrial system. And now I'm busy working on, well, we know crocodiles move into the water. How do we develop a water temperature model and get that accurately to predict when the crocodile is on the land versus when it's in the water, and what the temperatures are that it's experiencing, regardless of where it is in the habitat. And then from that, we'll hopefully be able to predict crocodile internal temperature. So this is just the first attempt at that, which looks messy and not quite right, but once I get that that water model right, we will see this looking a lot tighter, and again, strengthening that link between model predictions and reality. So with my last minutes, I just want to give you a quick little glimmer into what's next. And it's work that we're already starting to work on. It's this thermal landscape, quantifying the thermal landscape using remote sensing products, thermal drone technology, LiDAR, to be able to understand the landscape and then to populate those models with the type of physiological models I explained over here. And not just in Southern Africa, but also places like the Okavango Delta. So I've got this LiDAR data set where we'll be characterizing the different landscapes across here and then populating that also with these physiological limitations. And there's also some work happening in Zambia on ground nesting birds in that system. So with that, I would like to, those are the sites that we're working in. And with that, I'd like to thank you once again for listening to me, and hopefully in another year, I have even more exciting work to share with you.
Thank you, Shannon. We're looking forward to hearing how it progresses next year. Thank you so much. And unfortunately, there's no time for questions, but please do catch up with Shannon on the break, which is coming next. So just before that, please join me in thanking all the presenters for this session for amazing presentations and immaculate timekeeping. Just a quick announcement. We're going to be back from break at 11:10. And those who have the A0 posters at reception, please remember to collect them this morning. Yeah, thank you very much. See you later.